Did you know a computer can now invent art, music, and even faces from scratch? It's not science fiction, it's happening right now. Today we're explaining generative adversarial networks at 5 completely different levels, from kids to seniors. By level 5, you'll understand something most AI researchers debate about. Let's start with the basics. Imagine you're teaching a robot to recognize cats by showing it a million cat photos. The robot looks for patterns, whiskers, ears, paws, and gets better at guessing if a new picture is a cat or not. Now imagine 2 robots working together. One draws pictures, the other checks if they look real. That's how AI creates new things from scratch. These AI systems are called Generative Adversarial Networks, or GANs. They're like a team of artists and judges learning from each other. But how does the computer actually learn? Let's go deeper. You've probably noticed how TikTok suggests videos you might like, or how your phone finishes your sentences. That's AI learning from your behavior. GANs work the same way. They look at thousands of examples and find patterns to create new content that feels real. For example, a GAN trained on millions of cat photos can now invent new cat pictures that look real, even though they've never existed before. These AI systems are trained on huge data sets, sometimes millions of images, and use powerful computers to find patterns we can't even see. Now let's see what's actually happening inside the neural network. At the heart of GANs are 2 neural networks, the generator and the discriminator, that compete to get better at their jobs. The generator creates images, and the discriminator checks if they look real. If the discriminator says fake, the generator learns and tries again. This process continues for thousands of iterations. Each time the generator gets better at creating realistic images, and the discriminator gets better at spotting fakes. But GANs face real challenges, like overfitting, where the AI just copies training data instead of creating new things, or bias in the data it learns from. Now let's see what's actually happening inside the neural network. GANs are already transforming industries, from healthcare, where they create synthetic patient data, to fashion, where they design new clothing styles. But with great power comes great responsibility. GANs can create deepfakes, fake news, and even fake identities that are hard to detect. This raises big ethical questions. Who should be allowed to create and use this technology? And how do we protect people from being tricked? Businesses are also using GANs to automate tasks, which could change the job market and how we work in the future. And now, the perspective only time can give. Generative adversarial networks trace their roots back to a concept proposed in the 2010s. Today, we're closer than ever to an answer. Like the internet and electricity before it, AI is changing the way we live, work, and even think about what it means to be human. But unlike previous technologies, AI can create, not just copy, and that raises deep questions about creativity, intelligence, and consciousness. As we look back, we see a pattern. Every major technological breakthrough has changed the world in ways we couldn't have predicted. And scientists still can't explain why some GAN-generated images feel so real, or why some look like they're from another world. Which level changed how you think about generative adversarial networks?